continuation with the shape of the orbitals, as we discussed, the shape of s orbital, no direction, shape of p orbital, it has a 3 directions along the x-axis, y-axis and z-axis. Now when we are talking about shape of d orbital, so how can we get d orbital? L is equal to 2, right, and n is equal, so m is equal to, we have -2, -1, 0, +1 and +2. So total we have 5 orientations. So d orbital has 5 orientations and it has double dumbbell shape. And those orbitals are dxy is the first orbital, then we have dyz, then dxz. So these are the three orbitals which are lying between the axes, and 2 orbitals, that is dx square y square and dz square. So these are 5 orbitals, 5 orientations. 3 orientations are between the axis, between x and y, between y and z, between x and z, and 2 orientations along the x and y axis and along the z axis. Now, in all 3 cases, we have a double dumbbell shape. In this case, we have only one lobe along the z axis and there is a draft along the xy plane. So it is like a baby scooter. So these are the 5 orientations the d orbital has. Now after understanding this, let us consider what looks the atom. What will be the, not exact structure, how the electrons are arranged in this case. So first shell, so when I am saying n is equal to 1, so we can say 1s, right. Now since L is equal to 0, we have only 1. When I am talking about n is equal to 2, we have now what? 2s and 2p. When I am saying n is equal to 3, we have 3s, 3p and 3d. When I am saying n is equal to 4, we have 4s, 4p, 4d and 4f. When I am saying n is equal to 5, we have 5s, 5p, 5d and 5f. The next one will be 5g, but it has not still derived. It is unknown, and so on. So for 7 also we are writing 7s, 7p, 7d, 7f, like that. Now the next question will be, how are you arranging the electrons? To arrange electrons, we are going to use one concept, one principle called as Aufbaus principle. We are going to use Aufbaus principle. So Aufbaus principle. So Aufbau is a German word which means building up. What do you mean by that? The electrons are added from lower energy orbit to the higher energy orbit. Electrons are added from lower energy orbit to the higher energy orbit. So what is the criteria for lower energy and higher energy? That was defined by Aufbaus. So the first criteria is the lower energy orbit is one, or rather not orbit now, we'll say orbital. So the lower energy orbital is one which has lower value of n plus n. So lower energy orbit is equal to lower value of n plus L. Lower value of n plus L. So electrons are added from lower energy to higher energy orbital. That means increasing value of n plus L. Increasing value of n plus L. Now suppose we have same n plus L, then if n plus L value is same, then lower energy orbital is equal to lower value of n. Lower value of n. Now once we understand this one, now we can start adding electrons. Okay. So lower value of n plus L means in this which has the least value 1s. 1 plus 0, 2 plus 0, 2 plus 1, 3 plus 0, 3 plus 1, 3 plus 2, like that. So obviously first electron enters where? In 1s orbital. Now once 1s is filled, how many maximum electrons we require? What must be the orientation of those electrons? All that we'll see later on. First of all, we'll see if 1s electron is filled, orbital is filled, then it goes to the next lower value, that is 2s, right? After 2s it goes to the 2p, then it goes to the 3s, then it goes to the 3p. Now we have 4s and 3d, right? So 3 plus 2, 5, 4. So 3p goes to 4s, 4s goes to 3d, then 4p, right? Then 5s, then 4d, and so on. Now this is quite complicated. It looks complicated. So we can simplify it in a simplified way. The arrangement of electrons is like this way only. So according to Aufbau principle, after considering this arrangement, it's quite difficult to remember. So how will we proceed? According to the Aufbau principle, the electrons are added in this order. First electron enters in a 1s orbital, then 2s, then 2p, then 3s, then 3p, then 4s, 3d, 4p, okay, then 5s, then 4d, okay, then 4p, 5p, okay, then 5p will go for 6s, 6s, then we'll go for 4f, 5d, and so on, this way. In various books, the diagram is given in a various way. So whichever you feel simple, you can follow that. But the order of adding electron is like this way only. Rather, I suggest you to draw a diagram by yourself so that it will remember, and whenever we write electron in initial case, we have to draw the diagram so that it will help us to write the electronic configuration correctly. So the new electronic configuration is now in this format. Okay. So what will be the electronic configuration for some of the elements, and how many electrons we have to add in each orbital, that we'll discuss in the next session. Thank you.